We propose Focus Bug, learning environmental awareness for efficient mapless navigation. Navigating in dynamic environments with resource-constrained robots can be challenging. Traditional map-based methods are robust, but they can be computationally prohibitive. Moreover, dynamic environments make it difficult to keep an accurate map, limiting their ability to navigate. A lot of work has been done on accelerating navigation methods by designing specialized hardware such as task-specific chips or proposing algorithmic optimization, achieving great speedups. However, they are limited to specific robots or designed with fixed dynamics in mind. One common assumption of this method is that they process all the sensory data regardless of the situation. We propose FocusBug, a method for environment-aware mapless navigation. Our approach trains an RL-based agent that learns to select the most critical data points for obstacle avoidance. We propose an architecture combining the dynamic window approach, the tangent bug algorithm to act as a global planner, and our agent which selects the relevant data for robust mapless navigation. We train the agent to learn to select subsets of range data in dynamic environments in the AirSim simulator. We then deploy the agent on a small rover to perform real-world experiments with scenario containing static and dynamic obstacles. We evaluate FocusBug in a simulated scenario as well as in real-world experiments on a small rover to demonstrate it can generalize to unseen environments. We compare our method to the dynamic window approach with a full observation, the potential fields method, a rule-based baseline, and an end-to-end RL method. The results indicate that our method maintains the high performance of classical mapless methods while significantly reducing the processing time of the navigation pipeline. We also analyze the learned strategies of the agent by visualizing its decision-making. For the real-world experiments, we use different scenarios with static and dynamic obstacles. FocusBug is able to handle dynamic environments even when the obstacles are actively moving in their way, is able to safely navigate tight passages, and it is able to get around U-shaped obstacles that are usually posing problems to mapless navigation methods, demonstrating that an effective strategy to identify the critical obstacles was learned. Similarly to simulation experiments, FocusBug is able to generalize and maintain the high success rate of the dynamic window approach while reducing its processing time. In summary, our contributions are FocusBug, an RL-based method to learn environmental awareness, an approach combining our learning agent with classical mapless navigation methods to leverage the advantages of both domains, and simulation and real-world experiments that demonstrate the proposed method. The limitation of this work include the cross-discipline expertise that is needed to combine deep RL with mapless navigation methods, as both aspects need to be tuned with hyperparameters. Moreover, FocusBug only considers instantaneous data, meaning it could have difficulties avoiding obstacles moving at very high velocities. Finally, we find a trade-off between robustness and efficiency when increasing the rewards for data reduction. In future work, we hope to extend the scope of the learning agent to also dynamically control parameters such as the maximum velocity or control frequency to further leverage its environmental awareness. It will also be interesting to explore extending this principle to map-based navigation, where the processed information for navigation is even larger.